Hello friends, I'm sure you are doing great. Preparations are in full form and we are in our geometry module as you know. I hope you have noted all the things and you have memorized everything about lines, angles, triangles and polygons and quadrilaterals. Yeah. So next in the sequence as we had discussed already is circles. Yeah. So we are in the world of shapes. First we discussed all about lines, angles, triangles, then polygons and quadrilaterals, and the next big thing is circle, one of the most important topics in geometry after triangle. Okay friends, so let's explore all the concepts. Be ready with your pen and paper. I'm sure you are, pen and notebook, whatever. So let's see. First, obviously, all the basics, vocabulary, all the terminologies, knowing the members of the family of circle. Yeah, cool. So you know how a circle is formed, you know very well. You take a fixed point and you think of a fixed distance. Then keep joining all the points as you saw just now, which are at a fixed distance, at that same fixed distance from that fixed point. Check. Okay. So the radius is that fixed distance. So that fixed point was center. Cool. Yes. Then diameter, double of radius. It's nothing but the segment joining any two points on the circle and passing through center. Okay. So this is your diameter, double of radius. Cool. Great. Circumference. What is another word for circumference? Yes, boundary. So distance around the circle. The formula is perimeter. Sorry, it is also called as perimeter, and the formula is 2 pi r, and pi r into 2. So r into 2 is nothing but diameter, isn't it? So circumference can also be called as 2 pi r or pi d. Cool. Then semicircle, the prefix semi you have already seen many times. You have seen perimeter, semi perimeter. So it means something to do with half. So half the circle, correct? Something like this. Okay. All right. Acha. In case of semicircle, what will be the perimeter here? This curved portion, which is exactly half of the original circle, full circle. So half of 2 pi r. So basically pi r. Yeah. But not only this, plus can you see this also is a part of the boundary only, friend, and this is nothing but diameter. So basically perimeter is ultimately pi r plus 2r or pi r plus d, and area will be half of the full circular area. Also one more thing, just wait. Okay, so till now we have not discussed area. So area of the circle, sorry, one moment. So here area of the circle is nothing but pi r square. And if you want in terms of diameter, r is, you know very well, half of the diameter. So pi d square upon 4. You should be comfortable with both. Okay. Then if I talk about area of semicircle, simple, half of the full circle area. In this case, area will be pi r square by 2. Okay. And then you can replace r with d by 2. All right. Secant. Next term to be understood is secant. It's just a line that intersects circle at 2 points. At 2 points, okay? Something like this. Okay. Then chord. Chord. This is also intersecting circle in 2 points. So you might feel what's the difference. Secant was a line. Chord is a segment. Okay, that's the difference. If you understand, if you remember the difference between the line and the segment, that is the whole difference between the secant and the chord. Okay. Now some properties of chords, let's understand right away. Perpendicular drawn from center of the circle to any chord bisects the chord. Very useful. It will be used quite frequently. You will see in the questions. If you draw a perpendicular from center to chord, this red line, it will bisect the chord, means this point will be the midpoint of the chord. Both the halves will be equal. Equal chords are equidistant from the center. So if you take the same length chord, okay, its distance from the center will be same as the earlier distance. Okay, next, equal chords cut off equal arcs. See this red portion. Arc is nothing but the part of the boundary, part of the circumference. So if the chords are equal, naturally the chords they will the arcs they will cut off will also be equal. Okay, next thing is diameter. You can also see diameter is also a segment joining any two points on the circle, satisfying this definition, but it is also at the same time it is passing through the center, because of which it becomes the longest chord. So diameter is the longest chord, very easy to visualize. Okay, so as we move towards center, as the chord moves towards center, its length increases, and highest length will be the diameter. Correct. All right. I'm sure you're noting it down. Next point. Tangent. Yeah, it's also a line, but that touches the circle at one point. See this. So secant was cutting the circle at 2 points, and tangent is touching the circle at one point. That's the whole difference. Yeah, now some properties of tangent. Radius is perpendicular to the tangent at its point of contact. Very, very useful, very frequently used. Next, from any external point, friends, if you take any point outside the circle, two tangents can be drawn to the same circle. See this. And of course, as circle is a symmetric figure, both the tangents will be of same length. Okay, both these tangents will be of same length. And how do we measure the length of the tangent? From this point to the point of contact on the circle. So PA is equal to PB. Okay, remember all this. Great. Arc. Sometime back we had this word, equal chords cut off equal arcs. What is arcs? It's a part of circumference of the circle. So this much is the arc. All right. Now, how do we define the measure of the arc? It is nothing but the angle it makes at the center. See this. So if we say measure of the arc, it should click immediately that it is nothing but the end points of arc are making some angle at the center. So center is like vertex of that angle. So whatever that measure, that will be the measure of the arc. So if this angle is 60 degree, so we can say that this arc is of measure 60 degree. Like that, likewise, we can say full circle makes subtends 360 degree at the center, right? Something like that. So if the measure of the arc is less than 180, we call it as minor arc, and if it is more than 180, major arc. So you should be comfortable with these words as well. Minor arc, major arc. All right, cool, comfortable. So till now, what are we learning? We are learning all the individual members of the circle in detail. Then we will see all the other major properties. Okay. So this was minor, and this blue one is going to be major, right? Because that angle is more than 180. We also call it as, remember, reflex angle. Yes. Great. Angle subtended by an arc at any point on the circumference. Angle subtended by the arc at any point on the circumference are equal. See this. So whenever this arc will make any angle on the circumference, all of them will have same measure, and these angles are equal to half the angle it makes at the center. This is our inscribed angle theorem. So this will be 2 alpha. So angle at center is double of the angle at circumference. Inscribed angle theorem. In short, this angle is the inscribed angle of this arc. So basically this arc has inscribed an angle in the other arc. Okay. And that inscribed angle is half of the central angle. You can also call it a central angle or measure of the arc. All the terminology should be very, very clear, friends. You should be comfortable with all this. Okay. All right, let's go ahead. Length of the arc. Now, how do we connect? Full circumference is 2 pi r. But when does it happen? When the angle made at the center is 360 degrees. Now, if suppose this particular length is L, then at that time angle is theta, cross multiply. Yeah, angle at the center is theta. So after cross multiplying, you'll get this result. So this proportion of full circumference. So if this angle is like 180, it is half of full circle, full circumference, right? If it is 60 degree, it is 1/6, like that. If it is 90 degree, it is 1/4. Logical, isn't it? Understood till here? All right. Next is sector. You must have heard this word very often. And generally, in terms of the particular area, we say that that is area sector number 24, that is sector number 12, something like that. So it is relating to area only. So it's a part of the area of the circle enclosed between the two radii and an arc. See this? Something like the slice of the pizza. Okay. Yes. Or the cake, whatever. Yeah, I know. Now, why it is minor sector? Because this angle is less than 180 and the other one is more than 180. So it's a major sector. Okay. All right. Now, how do we define the area of the fact sector? How do we find it? Simple connection. When area is pi r square, at that time angle made at the center is full angle, right? 360 degrees. Suppose the area is now A, at that time angle is theta degrees. Cross multiply. So you will get this relation only, friends. So this much proportion of full area. Arc was part of the circumference. Sector is part of the area. Okay. Segment of a circle. In general, just the word segment tells us line segment. But if they want to talk about segment in context of circle, they'll have to tell us that segment of a circle. What is that? Check this blue portion. So it is nothing but the area enclosed between the chord and its corresponding arc. Okay, that is called a segment of the circle. Now, perimeter, no fixed formula. You can see in this boundary, there are two things involved, this arc and this chord. Okay, so this is the length of the arc, just now we studied some time back, and plus length of the chord, which we are denoting it as C. Now, area, how do we find area of that? You can easily plan with the two known things, area of the full sector minus area of that triangle, right? Area of full sector minus area of this triangle, and for finding area of the triangle, we are using two adjacent sides and the angle between them. Okay. So I hope you remember that area of the triangle formula in which two sides are involved and the angle between them is known. So half AB sine theta, A and B both are R. So this is how we can plan the area of this segment of the circle. Okay, comfortable till here? All right. Next, something about diameter. You know diameter and the angle subtended by the diameter with respect to circle. This topic is about that. So it subtends a right angle at a point on the circumference. Okay. Anywhere if the point is on the circumference, that angle is 90 degree. Cool. Okay. Remember that inscribed angle theorem, because with respect to the semicircle, this is 180 degree. So this will be half of that, 2 alpha and alpha logic. Remember, based on that only we could derive this. Now keeping this as a reference, we can also say if the point is inside the circle, so angle subtended will be more now because point is closer to the diameter. So this angle is more than 90. So this is obtuse angle. Similarly, friends, if the point is outside the circle, then the distance is away. That point is away from the diameter. So angle will be lesser and reference is 90. It is beyond the circle. The point is outside the circumference. So that angle will be less than 90. You can easily visualize and check. Okay. All right. So remember these three facts about diameter. It may help you to eliminate the options. Cool. Okay, now general properties. Before that, one more thing. No, something about ring. When I say ring, you all obviously know, you can visualize, you have seen what is a ring. So something like two concentric circles. Now, what do I mean by concentric circles? Circles having same center, concentric. So you can see these two circles are having same center. Circles with same center, this portion is like the portion of the ring. So circumference will be the circumference plus outer circumference. I'm just denoting the inner radius with small r and outer radius with capital R. Okay, so 2 pi r plus 2 pi r, capital and small, 2 pi common. Area will be like outside area, area of the bigger circle minus area of the inner circle. Yeah, I hope you could understand. So concentric means same center. Congruent circle means circles having same radii. So concentric, congruent. You should be clear with. All right. Next is tangent circles. I'm sure you remember what was the tangent. It's about touching a line in a circle. Similarly, tangent circle means now two circles are touching. You know that touching can happen in two ways. Circles touching each other internally. This is how the internal situation is. So what is the condition for this, friends? So the basically the distance between their centers. So this distance will be nothing but the bigger radius minus smaller radius, right? In this case, distance between the centers will be difference between the radii, bigger minus smaller, obviously. If they touch externally, this is how you should visualize, right, friends? External touching. And how will you come to whether the circles are touching externally or not? Distance between the centers will be nothing but the sum of the radii of both the circles, isn't it? How will you find distance between the centers? The coordinates will be given to you and you'll use distance formula which we have done in coordinate geometry. Okay, so this is your tangent circle. I hope you understood. Now one more thing I want to tell you, that if you take three non-collinear points, connecting all of them, you can draw only one circle. So only one circle can pass through three non-collinear points. And you can easily visualize this. Remember, three non-collinear point will also give you a triangle, and a triangle has only one circumcircle. Okay, cool. Now, suppose if I take a fourth point, D, don't you feel that fourth point has two choices? Which two choices? Whether to lie on the circle or somewhere outside. Suppose if the point D lies on the circle, then we say that all these 4 points will be called as concyclic points. So sometimes if you see this word, don't get scared. This means it's about 4 or more points lying on the same circle. So if 4 or more points lie on the same circle, they are called as concyclic points. Okay. All right. Now some general properties. The first one. Okay. So general properties. Till now, what did we learn, friends? Let's have a quick recap. All the individual basic properties and family members knowledge, all the basic vocabularies, right from center, radius, diameter, chord, arc, secant, tangent, their properties. Okay, tangent, circles, concentric, congruent, concyclic points. Yeah, all about arc, all about sector. Correct? Great. I hope you're comfortable till here. Now some more properties. First, cyclic quadrilateral. Quadrilateral we know very well, four-sided polygon. Now when does a quadrilateral become a cyclic quadrilateral? A quadrilateral whose all the four vertices lie on the circumference, something like this. Then it is called a cyclic quadrilateral. Now how will I identify this? The simplest way is opposite angles of a cyclic quadrilateral will always be supplementary. Supplementary, remember, sum is 180. So A plus C will be 180. Similarly, B plus D will also be 180, right? Great. Next, a cyclic parallelogram is always a rectangle. So if you try and draw a parallelogram inside a circle, by default it will be a rectangle. Similarly, a cyclic trapezium will always be an isosceles trapezium. I hope you can recall, remember what all about isosceles trapezium in our quadrilateral video. Oblique sides are equal. Cool. Now, area of a cyclic quadrilateral. How do we find the area? Again, something like that Heron's formula. So we have denoted all the four sides by ABCD. S is the semi-perimeter, which will be nothing but A plus B plus C plus D whole divided by 2. Perimeter divided by 2. Correct, friends? The root of S minus A, S minus B, S minus C, S minus D. Yeah? Comfortable? Great. Cool. Now, tangent secant theorem, also called as alternate segment theorem. So we have a angle between a tangent and a secant at the same point. See, this is the tangent, and from that same point of touching, a secant is drawn. So angle between them is alpha. Comfortable till here? So angle between this tangent and the secant. The vertex is nothing but the meeting point of the tangent and the secant. This is equal to the angle made by the enclosed arc at any point on the circumference. So enclosed arc is this blue one. So wherever this angle will subtend an arc on the circumference, means that inscribed angle thing, that will also be alpha only. So you can see this is like segment. It is making an angle in the alternate segment, the baju wala segment. Hence it is also called as alternate segment theorem. Very important. Generally, this doesn't click that fast, but please remember. Similarly, if this is beta, so the enclosed arc is this, isn't it, friends? Which has inscribed an angle beta on the circumference. Okay. Tangent secant theorem, alternate segment theorem. This is it. Cool. Understood? Comfortable? Okay. Now it's about two secants intersecting. Now there are two cases, externally and internally. First, let's talk about the case of external intersection. So P is the meeting point of both the secants and P is outside the circle. First property is about length. PA into PB is equal to PC into PD. So just note it, PA into the AB is wrong. PA into full PB because it is derived through similarity. Okay. All right. Similarly, next point is about angle. How do I find the angle between these two secants? Can you see these two secants have enclosed two arcs, arc AC and arc BD? Yes. So difference between the measure of those arcs and half of that. Can you recall? Measure of the arc means what? Angle subtended by the arc at the center. Check this. So here the measures are alpha and beta. So alpha minus beta, the whole divided by 2. Okay. All right. Now, secants or chords intersecting internally. Why am I saying chord? Because now it is internal intersection. So I can limit them till the boundary of the circle. So it can be called as chord also. Correct? Yes. First property is something very similar. PA into PB is equal to PC into PD. Start from that point of intersection and connect all the four lengths. So PA into PB is equal to PC into PD. Second is about angles. So BPD or APC both are same because vertically opposite angles. Again, they have enclosed two arcs, isn't it? AC and BD. So now it will be plus sum of measure of both the arcs and half of that. If the point is outside, friends, angle will be lesser, then subtraction. If the point is inside, angle will be bigger. So hence plus. Something like this you can remember. So alpha plus beta divided by 2. Okay, cool. Next is about a tangent and a secant intersecting externally. See this. So this one, PB is a secant, PC is a tangent. So first property is about length only. PA into PB is PC square. PC into PC, so PC square, same thought. Second is about angle. So this angle APC is nothing but the measures of these two arcs, difference of that divided by 2. Difference, right? Because the point is outside. Point is outside, so angle will be lesser. So half of difference between measures of these two arcs, friends. Getting it? Yes. So alpha minus beta divided by 2. Whole divided by 2. Okay. Just keep on revising again and again. These things will be clear, friends. Common tangents. Of course, the word common itself is very easy to understand. It's a tangent to two circles simultaneously. So this is a common tangent. This one is specifically called as direct common tangent. How to know it's a direct common tangent? Because the other one is called as transverse common tangent. After this, we will see that. So in this case, you can see both the circles or both the centers are on the same side of this line PQ, of this tangent PQ. So when both the circles or centers are on the same side of the tangent PQ, then we say that both then this tangent, the common tangent is called as direct common tangent, and in short form I'll call it as DCT. I'm interested in finding the length of this direct common tangent. Now friends, I think I forgot to tell this point in the triangles video. Whenever you're talking about length, see how you should think. First choice, Pythagoras theorem. Yeah. Second choice, similarity. If that doesn't work out, then area. These are three very famous and frequently used. Then other three rare cases. Next is if you talk about median ka length, Apollonius theorem. Then triangle inequality, that sum of two sides should be more than the third side, like that one. And finally trigonometry. So these are the six choices, six key thoughts which will help you to plan for the length. Okay, the most famous one is Pythagoras. Yes, let's see, let's do the planning. You know very well this radius and tangent, they are perpendicular to each other at the point of contact. Okay friends, yeah. Now how should I plan Pythagoras? Because right angle is involved, we can check what all will be given to us, the distance between both the centers and both the radii. If we know this much, we can plan for the length of this PQ. Check this. I want to find this L. So I am drawing a line parallel to AB. Drawing a line parallel to AB like this. So that will also have a length D. Can you see a right angle triangle getting formed? That was a talent. Yes. So let's see this separately. That was L and the hypotenuse is D. What will be this other perpendicular length? Yes. So this much was difference between R1 and R2, right? Because this much is R2 because of being parallel line. So this much will be R1 minus R2, isn't it? Now Pythagoras. Yeah, so D square is equal to L square plus this square. So L square will be equal to D square minus R1 minus R2 the whole square. So ultimately length of this direct common tangent is D square minus difference of the radii square. What is this D? It is nothing but the distance between the centers. In case you forget, so you can plan like this, Pythagoras. Okay, great. Next, transverse common tangent. Now you will see, you'll understand yourself. Both the circles or both the centers are on the opposite side of this tangent. Correct? Again, both the radii will be known. Distance between the centers will be known. Using this, we can plan and find out the length of this PQ. Again, I have to, the smartness is how will you plan Pythagoras? Yes, check this. Draw a line parallel to AB. Yeah. Starting with Q. Correct? So that extra extension on the radius side is R2, right? This and this will be equal because of being parallel lines. So now can you see this triangle? Yes, a right angle triangle. Yeah, hypo is D, other one is L, and this much will be what? Yes, R1 plus R2, Pythagoras. Straight. So this time it is sum of the radii. In the direct common tangent, it was difference of the radii. Okay. All right. One more shortcut I would like to tell you. You'll see those in the questions, some tricky questions. One more point about cyclic quadrilateral, friends. Ptolemy's theorem. What is Ptolemy's theorem? The product of the diagonals is equal to sum of the product of its opposite sides. So diagonals are AC and BD. So AC into BD will be same as, take the opposite pairs, AB into CD plus AD into BC. This much you should remember. One more point about cyclic quadrilateral. Now, if a circle touches all the four sides of a quadrilateral, the sum of the two opposite sides is equal to sum of the other two. See, this is a quadrilateral ABCD, and a circle is touching all the four sides. So circle is inside. So AB plus CD will be same as AD plus BC. You can easily derive this by, you can look at it like this. If this is like x, this will be x, tangent from a point outside the circle, that property. This is y, this is also y, this is z, so this will be z. This is w, this will also be w. Substitute in LHS and RHS, you'll see that both the things will match. Okay, so remember this as well. One more shortcut, one more special case. It's about three circles touching each other like this, and we have two common tangents like this. See, so I have drawn all these radii r1, r2, r3 perpendicular, clear. Then draw these two parallel lines. Yes, the meeting point is B and D. Check. So BC will be R1 plus R2. So BC will be same as distance between these two centers. DE will be same as distance between these two centers, R2 plus R3. The way we had derived in direct common tangent. So this much will be R1 minus R2, AB, and CD will be R2 minus R3, right? Correct? Okay. Look at these two triangles. These two triangles are similar triangles. Okay. Yeah, a test. So ratio of the corresponding sides AB over CD is same as BC over DE. Substitute the values, cross multiply, simplify, 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 and at the end you'll get this structure. R2 square is R1 into R3. And it's a very familiar known structure. We have done this in averages. If A, B, C are in GP, then middle squares go to first into third. Yeah. And if you have 2B is equal to A plus C, then ABC are in AP, right? And if 2 upon B is equal to 1 upon A plus 1 upon C, then ABC are in HP. This is harmonic mean. B is harmonic mean. Remember these three famous structures. So B square equal to AC kind of structure, we found this here. So R1, R2, R3 are in GP. So whenever you see such situation, exactly the same situation. So the radius of the first circle, second circle, and third circle, they all will be in geometric progression. Then the sum becomes very easy to solve very fast. All right. Okay. Cool. So that's it about circles, friends. This much is the bare minimum content which you should have before approaching the questions of the circles. Thank you for so much for giving your valuable time listening to me and noting your concepts well. Okay. Keep revising, keep refreshing through those. Yeah. So thank you so much. Take care, stay safe. See you in class. Bye.